So in this video we're going to find the power series for cosine by using the power series for sine. Now, power series for sine of x, I just put that up on the board so we can have a look at what we're dealing with. We've got the summation from n equals 0 to infinity, and then we've got a fraction which has got an alternating series minus 1 to the n, and then we've got x to the power of 2n plus 1. Now sine is an odd function, so hence we'll always have an odd term in our x power there. So whatever n is, that will always be odd. And then we divide that by 2n plus 1 factorial. So that's what we've got for our power series for sine. Now what we're going to do to find the power series for cosine, we can take the derivative of this. And then the derivative of sine we know is cosine. So if we take the derivative of this, this should give us the power series for cosine. So let's just write down here dx of sine of x. That equals, if we take the derivative of this, so that equals the derivative with respect to x of this power series. So n equals 0 to infinity, minus 1 to the n, x to the 2n plus 1, and then divide that by 2n plus 1 factorial. Okay, now if we're going to take the derivative of this, the derivative of the sums is the same as the sum of the derivatives. So we can flip this algebra around. So now what we can have is n equals 0 to infinity of the derivative with respect to x of this term here. Now this term here, I'm just going to change it a little bit to help me find my derivative a little bit easier. So minus 1 to the n, x to the 2n plus 1. Now I'm happy with that, but my denominator 2n plus 1 factorial, I'm just going to write that a little bit different. 2n plus 1 factorial is the same as having 2n plus 1 times 2n factorial. So the 2n factorial I would write like that. So that will give me that term there. So then close off my brackets. Now what I need to do is just take the derivative with respect to x. So let's just do that now. So we've got n equals 0 to infinity. Derivative with respect to x. So there's some terms here that don't involve x. So I can rewrite these straight down here. So I've got minus 1 to the n, 2n plus 1, and 2n factorial. So there's no term there with x. So taking derivative with respect to x, I can just leave those in. So there's a lot of stuff there, but all we're going to be interested in now is x to the power of 2n plus 1. Now if we just apply the power rule to this, so remember the power rule, we drop the power by 1 and the original power we bring out to the front. So now we've got 2n plus 1, and then drop this power by 1, we're just left with 2n. So now we can just simplify this, and this should give us the power series for cosine. So 2n plus 1 and 2n plus 1, these cancel out. And now we're left with, so that equals, so n equals 0 to infinity, minus 1 to the n, x to the 2n, and then just 2n factorial. And that there is my power series for cosine by taking the derivative of the power series for sine. So then therefore that is our answer. Okay.